Today we're going to be looking at creating embers inside of Fusion using its native particle system. Let's get started. First thing we're going to do is open up a new shell. I'm going to set my environment variables and start up Fusion. Now this is going to work with the free version in Fusion as well as the Studio Edition. I'm going to change my layout to something that I prefer. We're going to drop down a P emitter and a P render. Let's change the, let's just leave it playing for now. Let's change the region to rectangle, make it a bit wider, angle it 90 degrees down, and go to the controls tab, maybe add a bit of velocity. We need to change the angles to 90 degrees so it's all flowing upwards. Embers have a tendency to rise wherever there's heat, so we'll add a bit of variance to it. Maybe something like this. I think that's starting to look pretty good, but we need some swaying, swooping motions, so you want something like peak turbulence, which just adds noise to the motion of the particles. So I'm just gonna link these two so they're all moving together with the top parameter, and we'll adjust the density. So the lower the density, the lower the frequency of the noise, so you'll get much bigger swoops. Kind of the density is the same as the frequency, while the strength is equal to the amplitude. Okay, so I think that looks pretty good. Let's drop down a background node because we're now going to create the look of the sprite itself. So we're going to make this a small sprite of 128 by 128. Make it white and connect a mask input to it. We're going to make it long and thin. And let's connect it to the P emitter, but before we can do that we need to change the style from point to bitmap. Then we can connect it. What we have now is the sprite connected to each one of the particles, but the orientation is completely wrong. So you want to go to the P emitter controls, rotation controls, and set it to relative to motion, and turn off always face camera. Now if we have a look, they're probably way too big, so you want to go to the style section, tone it down quite a bit, maybe adjust the size variance, so some of them are bigger than others. Something like that looks pretty cool. For color controls, I want to change the, or not change, but modulate the color over time. So let's say they can be white for some period of time, then they can be orange, then they can be red, and then they can be, yellow again, and then maybe even white, and then yellow and orange and yellow again. So if you play this back now, you'll see that they'll change colors, and you get a much more of an interesting range of particles. I'm just going to go to the P render and set it to pre-generate 24 frames, just because I don't like waiting for the first couple of seconds to see what's going on. So that looks pretty interesting. We'll drop down a merge node and a camera, and we'll connect everything together. We can now copy the point of view to the camera and switch it to the camera view. If you drop down a render node now, let's see what we're actually going to render. So for starters, this is a very small image, so let's change it to something like 1280 by 720. And it's set to the OpenGL render. And the OpenGL render is very fast, and it provides you with a bunch of additional effects that you can't get from the software render. Now the software render is really good. It provides terrific anti-aliasing. You can get anti-aliasing in the OpenGL by enabling super sampling, but we're not going to do that. We're going to set the transparency mode to fast, or Z-buffer, and the difference between these three is how much transparency you got in your scene reflects how decent the quality of the depth sorting is going to be. So if you have very thin smoke that you're trying to composite, you might want to set it to sorted or accurate. If you have hard surface stuff that doesn't have much transparency, like in our case, you actually want to set it to fast. So with that said, Fusion has in the OpenGL tab something called accumulation effects, and that is an OpenGL way to render 3D depth of field. So let me just bring down the amount of blur, and let's bring up the amount of samples to something like 32. It's quite dark, so let me just put down the color corrector and gain it up. What the accumulation effect actually does is it accumulates, as the name implies, 32 different images on the GPU with a slightly offset camera, and together it's all averaged together to produce this result. And you can kind of see these individual grains or individual samples of how the cameras have been moved around. But what it provides you then with is an ability to do proper 3D depth of field in comp without cheating. So if you click on the camera, you can now change the plane of focus interactively and find something that looks pretty good. So I'm just going to tweak some of these a little bit. Maybe we're going to need 256 passes on the GPU, and it's still, pretty fast. Okay, so with the color corrector selected, I think we should try and play a little bit with the colors of things. Maybe we need to do a bit more orange. Maybe the mid-tones needs to be boosted, and even maybe desaturated just a little bit, and the highlights could actually be desaturated too. Maybe we'll just add an overall contrast to the image and increase the depth of field just ever so slightly. And let's actually increase the amount of points or particles. The number variance is just the variance for each frame of how many points can be spawned in addition to the numbers. So let's have a look and see what we got. Okay, so far so good. I still think we might need to speed up the overall velocity if they're moving upwards. So we can go to the velocity tab, just move it up a little bit, add a bit more variance to it, and maybe even the turbulence can be increased a little bit, just to create an even more, to create a sparser distribution of the points as they move. Okay, so that looks pretty cool. Let's start adding a couple of post effects. So we'll do a little blur, we'll blend it back, we'll do that again. This is just to kind of smear the colors around. Something like this, something like this. And maybe we'll even do a really, really big one. Maybe 1,000. Blend it all the way back. And we can go back to the color corrector and maybe boost it. Something like 9. 10 even. Maybe on the camera side we'll just change the focal length, so we'll zoom in on just a little bit on the image. Let's increase the amount of points by a fair amount, so something like this. I think that's starting to look pretty interesting. Still a bit of uniformity to the feel of the sprite, so let's change that one. Yeah, I think that looks pretty good. This concludes this tutorial on creating Ember.